Hi, so in this video we are going to talk about the second method. So let's get started. I'm going to include the IO stream and I'm going to include the mass.h. Okay, I'm going to use the namespace standard, and I'm going to define, for example, fx to the power x 2 minus 2, which is, as earlier, it is x to the power of 2 minus 2, it is the function, and we want to get the equals to 0 because we are searching for the root, and is the square root of 2. We want to get the square root of 2. So we have a void secant method. We have a double x is going to be a reference. We have a double x 0 and we have a double x1. As we have discussed in the theoretical section, we have two initial positions. Okay, and while the fabs that fx fx1 is greater than the error term. Of course, I forget to define the error term, so we have a constant double error is equal to 0.001, for example. We just have to x is equal to x1 minus fx1 times x1 minus x0 divided by fx1 minus fx0. And I think another is missing, fx0. Okay, so that's why I said that it's something like a derivative, but we don't have to calculate the derivative. Sorry, it's not times, but it's a minus sign. It's something like the derivative, but we don't have to calculate the derivative explicitly, and that's why it's very, very good, because sometimes calculating the derivative is very, very expensive, and we just have to update the references. So x1 will be x0, x1 is equal to x, and that's all about the second method. We will have an int main, and we will have a double x is equal to 0, double x 0 is equal to 0, and double x1 is equal to 10, for example. And we just want to run the second method with the x, x0, x1, and we just like to see out that the solution is x with end line. I'm going to return 0. Okay, so let's build the project. Let's run it. We should get approximately 1.41 and so on. And something is not good. X, let me think about it. x1 minus f x1 times x1 minus x0. Yeah, because I'm missing divide by f x minus 1 and something like this. Okay, at least I think that was the problem. It's not sure. There was a solution. Okay, so approximately it's working fine. If we set the error terms to smaller, or just the second method to run a bit preciser, then we can do something like this. We can have a guess what's the square root of 2. It must be between 1 and 2. Yeah, and it will be a bit more better solution. So that's all about the second method. As we discussed, it's good because it's something like a derivative. It's something like a derivative, but we don't have to calculate it explicitly, and we have 2 initial points. Yeah, that's all. Thanks for watching.